Currently, one of the biggest problems our world is facing is global warming. In just 100 years, Earth has warmed about 2 degrees due to climate change, and this has brought many issues with it. Drought, which is caused by global warming, is becoming more and more harmful each passing day. If you want our world and our children to have a bright future, we have to protect our precious water resources that are threatened by drought. The biggest threat to our water supplies is agriculture. About 70% of the world's fresh water is used during farming. Many lakes, rivers, streams, and groundwater around the world have been withdrawn or dried up because of cultivation, just as the Aral Sea has been destroyed during cotton farming. As a result, in our country, Turkey, there has been a serious decrease in groundwater. The waters have been reduced by 70% in Tekirdağ, and sinkholes have started to form in Konya, Karaman. Because of drought, many people are dying as they can't access clean water. They have to drink unsanitary water they find in muddy ground or even worse places. These upsetting, tragic photos taken in Tanzania have been sent to us by the Tanzanian ambassador's wife herself. If we cannot stop the excessive and uncontrolled use of our water sources, we will face grim consequences in the future.
Hello, my name is Orhan Serkan Tola.
And my name is Sabahat Mataköksal.
We are 11th graders in Bahçeşehir Science and Technology High School, and today we will present to you the Peltier Humidity Condensation and Irrigation project.
Our aim in doing this project is to reduce the amount of water taken from water sources such as lakes, rivers, and underground waters during agriculture, and instead use the water we have condensed from the humidity in the air for agriculture. When we implement this system on farms, farmers will be able to have constant water supply to use during irrigation. Also, using the soil moisture sensor, irrigation will be automatically and more efficiently be done by adjusting the properties of the soil as well as the crops grown. The sensor will provide the data for specific crops, irrigation amount, and intervals. Combining the data with the water supply will help crops grow in the most optimal way. This way, since the constant need of clean water will have drastically decreased, our natural water sources will hopefully be protected. For this, we have created a system using Peltier cooling system to condense humidity.
Peltiers are thermoelectric coolers that include semiconductors inside. When current is applied to the semiconductor, one side heats up and the other side cools down below 0 Celsius. We will have placed aluminum plates on top of the cool side of the Peltier. The fans in the system will redirect the air to the aluminum plates. These aluminum plates serve the purpose of increasing the surface area where we can condense humidity. Then, thanks to sub-zero temperatures produced by the Peltier, the water vapor will trap in our system will condense into water. The condensed water will then drop down into our water tank to be stored until use. Naturally, when one side of the Peltier cools down, the other side heats up. The more efficient we want the system to be, the colder we need the hot side to be. For that, we have decided to attach liquid cooling systems to the Peltier's hot side. These coolers will keep the system from overheating.
For this project, we want to draw the air a few meters above the ground levels to not decrease the humidity close to the surface, which the crops will need. To achieve this, we designed a chimney-like system that stands from the system and rises up a few meters above the ground, draw the air. The important part of the system is that it has to be heat insulated. If heat is absorbed from the atmosphere of the area, it will drastically lower the efficiency of the system. As you can see, insulated the Peltier coolers as well as the water tank from heat.
Next, we have put soil moisture sensors periodically along the farmland. These sensors can use an Arduino chip that has a code that is adjustable according to the properties of both the soil and the crops. This way, in case of a moisture drop in the soil, the system can automatically irrigate the crops using water stored in the tank. Peltier cooling is a very electric efficient system. This means that this project can run entirely on solar panels. Unfortunately, the condensed water will not be rich in minerals, unlike water found in nature. However, we can use filters that contain minerals or additional fertilizers when mineral-rich waters are needed. Finally, we present to you our prototype of the system. Even though this is a very small-scale prototype, we still managed to produce 54 milliliters of water in just an hour or two. Sadly, the experiment was done without heat insulation, and this drastically lowered the amount of water we produced. During the experiment, we tried many different designs for the Peltier systems to see which one gave better results.
This was the end of our presentation.
Thank you.